Welcome to The Explainer. Today we're going to be detectives. We're diving into a medical mystery where the most obvious suspect, well, it might not be the real culprit. We're going to uncover the hidden clues and the false leads that can trick even the sharpest scientists, and we'll learn how to spot them ourselves.
So our case kicks off with a connection that seems, pretty simple on the surface. It's about two things we all know: sugar and heart disease. But as any good detective will tell you, the first suspect isn't always the one who did it.
You know how this goes, right? A study like this comes out and bam, headlines are everywhere. Sugar causes heart attacks. It's a simple and honestly a pretty scary conclusion. But here's the thing. Good science isn't about finding the easy answer, it's about finding the right one. And that means researchers have to stop thinking like headline writers and start thinking like detectives on a really tough case.
So, who are these detectives? In the world of medicine, they're called epidemiologists, and their job is to hunt for patterns of disease across whole populations. They start by gathering clues, usually with something called observational studies, which is kind of like a detective on a stakeout, just watching what happens without getting involved.
This right here shows two of their go-to methods. First, you've got case control studies. For this one, imagine starting at the scene of the crime, with people who already have heart disease, and then working your way backward, digging through their past for clues, like maybe a high-sugar diet. Then you've got cohort studies. This is the opposite. You start with a big group of healthy people, and you just follow them forward in time, seeing who gets sick. Both are really powerful ways to get those first essential clues. But almost right away, our detectives run into their first big problem. It's a real master of disguise, a trickster that can mess with the evidence from the very start. And its name is bias.
So what is bias, really? Well, think of it like using a crooked ruler that's always off by an inch, or a compass that never actually points north. It's a systematic error that just keeps pushing the results in one direction, over and over again. It can make an innocent suspect look guilty, or let the real culprit get away scot-free.
Now, two of the most wanted types of bias are recall and selection bias. Recall bias, that's like having an unreliable witness. Someone who just had a heart attack is probably going to think a lot harder and remember every single sugary drink they've ever had. A healthy person, not so much. And selection bias is like interviewing the wrong suspects entirely. If your healthy group is full of, say, professional athletes, they're not really a fair comparison to the average person, right?
Okay, so let's say our detectives are amazing. They've dodged all the bias, their evidence is clean. But there's another, much sneakier villain they need to look out for. This one is the hidden accomplice. And in the science world, it's called a confounder.
So here's the plot twist. A confounder is a secret third party that's connected to both your main suspect, in this case sugar, and the crime itself, heart disease. It just hangs out in the background, creating this fake link that makes your suspect look guilty just by association.
And in our sugar and heart disease mystery, this is exactly what happened. Researchers eventually found the hidden accomplice. It was cigarette smoking. See, it turned out that back then, people who smoked a lot also happened to drink more coffee loaded with sugar. And we know for sure that smoking is a huge cause of coronary heart disease. There's the connection.
Smoking was the confounder. It was linked to both the high sugar intake and the heart disease. So once the researchers factored in the effects of smoking, that scary direct link between sugar and heart attacks, it just kind of vanished. They had found their hidden accomplice.
This, of course, brings up the million-dollar question. How do our detectives finally pin down the real culprit? I mean, with all these false leads and secret accomplices, how do they prove what's actually going on? Well, lucky for us, they have some pretty amazing tools.
They've got some really clever techniques. One is called matching. This is where, for every person in your study with heart disease, say a 55-year-old man who smokes, you find another 55-year-old man who smokes but is healthy to compare them to. It's smart. But the real game changer, the absolute gold standard for cracking a case, is randomization. And this quote just says it all. In the research world, especially in these super powerful studies called clinical trials, randomization isn't just another tool in the box, it is the absolute core. It's the engine that lets scientists go from just seeing a connection to actually proving that one thing causes another.
The genius of randomization is just how simple it is. You take a whole bunch of people and basically, by a flip of a coin, you randomly put them into different groups. When you do that, it's like magic. All those other factors, their age, their lifestyle, their genes, you name it, they all get spread out evenly between the groups. All those sneaky confounders just cancel each other out.
And what you end up with is
Well, it's incredible. You get two groups that are practically identical. Now, the only major difference between them is the one thing you're actually testing. So if one group has a better outcome, you can be pretty darn sure your suspect is the real cause, and not some hidden accomplice.
So now you know the secrets. You have the detective's toolkit. The next time you see a headline screaming that X causes Y, you can take a step back, look a little closer, and ask that all-important question. Wait a minute. Could there be a confounder? Who's the hidden accomplice here?